Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju P. In this video, we are going to discuss about what is the generalized momentum. The generalized momentum, we also call it as a canonical momentum. We also call it as a conjugate momentum also, right? So in GATE, like that examination, people are asking the question based on the generalized coordinates. So this question belongs to the generalized coordinate. In GATE 2017, this question was asked once. You have to see the Lagrangian L0 is equal to, the Lagrangian L0 is equal to 1 by 2 m dq by dt whole square minus 1 by 2 m omega square q square is there, is modified to L is equal to L naught plus alpha q into dq by dt. Which one of the alpha q into dq by dt, which one of the following statement is true? So they are giving here two Lagrangians they are giving. One is unmodified Lagrangian equation. One more equation is modified Lagrangian equation they are giving. The two Lagrangian equation they are giving. Among the two Lagrangian equation, they are giving the options once. You have to see both the canonical momentum and equation of motion do not change. Both the canonical momentum and equation of motion. We need to calculate the canonical momentum and equation of motion. And B, so the canonical momentum changes, the first one, and the equation of motion does not change. So then the next option you have to see, canonical momentum does not change and the equation of motion changes. Both the canonical momentum and equation of motion changes. What is our ultimate goal? We need to calculate the canonical momentum, and so we have to calculate a equation of motion of the Lagrangian equation of motion. Equation of motion what? The Lagrangian equation of motion we need to calculate. First we have to solve. How we have to solve the canonical momentum? We able to see. What is our function? Our function is L0 is equal to, the first function I have to take here, L0 is equal to, L0 is equal to what they are giving, 1 by 2 m dq by dt, 1 by 2 m, so 1 by 2 m dq by dt whole square, 1 by 2 m into dq by dt whole square minus 1 by 2 m omega square k square minus 1 by 2 m omega square q square. So this one I am rearranging. First you have to take the first Lagrangian function. You have to observe the canonical momentum and equation of motion. 1 by 2 m into dq by dt is equal to q dot square minus 1 by 2 m omega square into q square. This is the Lagrangian. Now you able to find out the canonical momentum. How we have to find out the canonical momentum? You able to see the canonical momentum pi is equal to, what is our formula? Dou L0 by dou qi dot. This is the canonical momentum. Dou L by dou qi dot. So you are giving the L0 they are giving. That's why I have to write it as L0. So therefore you have to find out the canonical momentum is equal to m q dot. So this is the canonical momentum for the first one. Now you able to see the Lagrangian equation of motion. What is the equation of motion? The Lagrangian equation of motion is equal to, what is that formula? So d by dt of, so dou L by dou qi dot, so minus dou L by dou qi is equal to 0. So therefore you have to substitute dou L by dou qi dot is equal to, already we discussed that one, dou L by dou qi dot is equal to mqi dot. So d by dt of dou L by dou qi dot is equal to mq double dot minus into minus plus dou L by dou qi is equal to m omega square into q. m omega square into q is equal to 0. This is the equation of motion corresponding to the Lagrangian. So equation of motion corresponding to the Lagrangian, m qi double dot omega square is equal to q is equal to 0. Now you able to the second Lagrangian expression is L is equal to L0 plus what is that, alpha q into dq by dt, alpha q into dq by dt. I'm rearranging this expression. Once you have to see L is equal to L0, you able to take 1 by 2 m q dot square plus minus 1 by 2 m q dot square minus 1 by 2 m omega square q square plus alpha into q. So dq by dt is equal to q dot. You have to write it is alpha into q dot. You have to take. Clear? So therefore what we have to write here? So first you able to find out here the canonical momentum. The canonical momentum is equal to, what is our canonical momentum? You able to see what is the formula? So pi is equal to dou L by dou qi dot. So this is the canonical momentum. So therefore dou L by dou qi dot, in this term qi dot is there, m into qi dot it will come. In this term there is no qi dot, that's why it will able to take the 0. Here qi dot is there, alpha into q. So this is the canonical momentum corresponding to this Lagrangian function. Now you able to observe. So this canonical momentum you have to see, you able to observe here this canonical momentum and this canonical momentum. This canonical momentum is m into q dot. This canonical momentum is m into q dot. Some additional term is not equal. These canonical momentums are not equal. Now you able to take so the equation of motion. How you have to find out the Lagrangian equation of motion. The Lagrangian equation of motion, how you able to find out d by dt of, so dou L by dou qi dot minus dou L by dou qi is equal to 0. So therefore here you have to substitute here. So dou L by dou qi dot m qi double dot. So plus which one we have to write, alpha into, we have to take it as a once again you have to write it is so qi dot is not there. So now we able to take a, so that is minus into minus plus m omega square into q, m omega square into q, right? That is the dou L by dou q I is equal to m omega square into q it will come. And again you have to see here, so plus here you have to take it as a alpha into qi dot. So again you have to take that one minus alpha into qi dot is there, plus alpha into qi dot minus alpha into qi dot, you able to get cancel. So therefore you able to say m into q double dot plus m omega square q is equal to 0. So this is the expression you able to get the equation of motion. Now you have to observe the equation of motion. These two equations you have to observe. M qi dot is there, m omega square q, m omega square q. So these are equal is there. So therefore the canonical momentum is changes and the equation of motion is same, so similar. So therefore you able to see the options. What option you have to see? Both canonical momentum and equation motion does not change. One is changing. The canonical momentum is changes, that is correct. The canonical momentum is changes and the equation of motion does not change. The equation of motion does not change. This one also correct. So therefore option B is correct. So the canonical momentum does not change, not correct. The equation of motion changes, not correct. So both the canonical momentum and equation of motion changes. This is also not correct. Option B is correct. How simple you able to get the question? That is very very easy. Once you know the concept, it is very very simple. Like this you able to solve in your competitive examination. If you really likes my teaching, I am appealing to you. So first you download my app, that is Quantum Online Academy app. If you have Android mobile phone, you download from the Play Store. After downloading my app, you go for which one you go for? You go for the login into that app. After login into that app, you go to the stores. You able to see the courses we are offering the courses, that is the CSIR and GATE physics course. We are offering JL physics, DL physics. Not only that, individual papers also available is there. Till now the mathematical methods of physics is all mathematical methods of is finished. Now the classical mechanics, only two topics are left behind, that are Hamiltonian formalism and periodic motion. If the Hamiltonian formalism, periodic motion is finished, entire the classical mechanics is finished for the JL. But for DL, some topics are is there. Those things I have to teach after some time. So please share and like and subscribe our YouTube channel and to encourage us. Thank you so much.